So, good day everyone, and welcome to another episode of Learning Biostatistics with me. I am Mary Hartilam Alam, and today I'm going to teach you about chi-square test, the non-parametric test. So, the chi-square test of independence, also known as a Pearson chi-square test, is a non-parametric statistics, also called a distribution-free test. It is one of the most useful statistics for testing hypotheses when the variables are nominal. So, the purpose of this test is to determine if a difference between the observed data and the expected data, which is due to change or if it's due to the relationship between the variables. Here is the formula for calculating a chi-square. So we have the summation of the open parentheses, observed value minus the expected value, close parentheses, squared over the expected value. So before that, we must also calculate the expected value, which is the row marginal times the column marginal over the total sample size. So we have here the case study 1. So a biologist want to test the hypothesis that two species of seagrass associate with each other. So he sampled 7 quadrants and tabulated the presence or absence of the two species. So here we must create a contingency table to understand the scenario and test the hypothesis using chi-square test of independence. So we have here. So first, we must state the hypothesis. Here is the null. There is no significant associate with the Thalassia hemprichi seagrass and the Cymodiocia cirrata seagrass. And here is the alternative, which is there is a significant associate between those two seagrass. Yes, so first, to make a contingency table, we must first count how many presence uh, of this seagrass. If there's present absent, absent present, and absent. Yes, to tabulate the contingency table. So we have two present absent here, the quadrant 1 and 4. We have two also absent present, which is the quadrant 2 and the quadrant 6. We also have here the present, which is the quadrant 3 and the quadrant 5. And we also have here, lastly, 7, quadrant 7, which is only one, absent. So, next slide. We have here the table contingency table. Table 1. So yeah, as you can see, nakita nyo nga, there are two present, two absent present, and two present absent, and one absent. A total of 7. So to formulate, to answer the chi-square, or to solve the chi-square, we go to the Excel. So here we have the table, the observed data. So first, we must calculate the expected value here. We must times the row marginal and the column marginal here. Then divide it into the total number. So we have here we focus on this one. So we times its row marginal equals, highlight row marginal times its column marginal, and divided it with the total sum, which is 2.2857. And same goes with the everyone. Same pattern again. Because here, we highlight this and times its column marginal divided by total sum, 1.7. Because this one. Its row marginal times its column marginal divided by the total sum. So we have 1.7 again, and focus on this. So its row marginal times its column marginal. divided by the total sum, which is 1.2871. So here we have the expected values. So next is we solve this formula. So we have present. So equals open parentheses. Oh, what is our observed value here? 2. Then sign minus the expected value here is this 2.28, close parentheses. We put the caret sign, then squared over the expected value is this again, then enter. We have 0.03571. So same calculations will be given here also, and also there 0.01. So it's very easy. So we have this. Then to solve the chi-square is that we sum of this, diba? Summation of overall. So we sum this all. So equals sum open parentheses, highlight these 4. Okay. And enter. We have 0.19 for 4. So the DF, the degree of freedom. So to solve this, we have here number of rows minus 1 times number of columns. So we have here, we're gonna follow this table. We have 2 rows and 2 columns. So 2 minus 1 times 2 minus 1 is equal to 1. So put it here 1. So to have this p-value, we must put this function command equals to p-value CHISQ dot dist dot RT, then open parentheses, the squared value, then comma, then 1, the degree of freedom, close parentheses, and enter. So we have 0.65 here. So we have a p-value of 0.65 here. So we have this rule. So if the null, we must follow accept the null hypothesis if the p-value here is greater than 0.05, and also if we have to accept the alternative value if the p-value here is less than 0.05. So since our p-value is 0.65, which is greater than 0.05, then we accept the null hypothesis. We accept this. So therefore, there is no significant between the Thalassia imbrici seagrass and the Cymodussia circulata seagrass. Yeah. Thank you so much for your time, and I hope you learned something today. So if you guys have any questions, recommendations, or suggestions, you can message me on my FB account, Alam, or email me on my email, which is @gmail.com. So thank you guys. God bless, and that's all. Bye bye.